Hello everyone, this is Aditya sir, and in today's class we'll be talking about some of the principles or about some of the gas turbine engines. Let me remind you that these classes are particularly meant for students those who are preparing for gate examinations and taking aerospace, rocket propulsion and aeronautical sector as their mainstream or to build their career in that. Fine. When we try to start to talk about gas turbine engine, first we should be knowing what is exactly a gas turbine engine. So in order to see what is a basically gas turbine engine, let's try to begin with the concept of propulsion. So what is basically a propulsion? Propulsion is basically propelling something or pushing something by means of force which is generated by the engine. Okay, this is where the engine plays a role. The role of an engine is to propel something. So when we have a wheel or a bicycle, if we want to propel that bicycle, we convert our muscular energy and we paddle the wheel. By paddling actually we convert our muscular energy into mechanical energy, and that useful mechanical energy, it is then used to convert to rotate the wheel of a bicycle. Okay, similarly when we talk of propulsive systems like rocket engine or an aeroplane, there is a certain power plant, there is some mechanism working behind it in order to push that aeroplane in forward direction, right? So when we are talking about when we say a gas turbine engine, basically what does that name imply? So a gas turbine engine is basically gas turbine engine, basically it is an engine which works on gas, that means air or other kind of a gas. So an engine which works as a working fluid or working fluid as a gas, and then using a turbine. So it uses a turbine to generate a mechanical energy by means of a gas, and it converts, and during in this process it converts the thermal energy into mechanical energy. Okay, so here you can see this is the whole idea and the whole concept behind this gas turbine engine. The air, or you can say, because we are talking about airplanes, we are using air at present as a working medium. So this gas and this air, it has to be propelled at very high speed. Okay, very high speed from the exit, so that it generates a lot of thrust. Okay, we know Newton's second law of motion. According to the based on from Newton's second law of motion, we know that to every action there is equal and opposite reaction. Okay, so when we propel the fuel at a very high speed in this to the right hand side, obviously there will be a force to every action. So this is an action. Okay, this is an action. So to this action, there the nature will respond in the form of a reaction. So any unnatural thing we do in the nature or in atmosphere will always have some effect on the particular object. Okay, there is always some effect. So here we are doing actually action, and because of this high speed exhaust or jet or gas or air which is coming out into the atmosphere, this entire system will be propelled, or it will be pushed in the left hand side direction. So if we want to move in the left direction, we have to generate some force or some kind of mechanism which produces action towards the right hand direction, similar to that of a rocket propulsion. Here high speed fuel is actually burnt, and it is exhausted and it is exited at a very high speed, so that this rocket is pushed in the upward direction. Okay, so I hope everyone understood. Here gas turbine engine is basically called a gas turbine engine because it uses working fluid as air. We have abundant of air air in our atmosphere. So what we aeronautical engineers do is they take the air from the atmosphere and they try to use that air, speed up the air and exit it at a very high speed. So there is some mechanism this mechanism which is used to generate a high speed jet, that's called basically an engine here. So because working medium is gas, an engine converts thermal energy into or chemical energy into mechanical energy, useful energy, and turbine is used for that process. Okay. So this whole setup actually works on Newton's third law of motion. Then coming back to basics of an aeroplane, why do we need a propulsive unit? Why do we want to push something in the forward direction? So here, whenever we are actually flying in air, there are two most important forces other than this lift and weight. Obviously, if we are using a machine or if we are using a vehicle, it will have its own weight which is trying to put it down. Okay, pull it down. Okay, so we have to have some force which is trying to move it in upward direction, and it has to be, the lift force has to be actually greater than weight of the object, then only we will get airborne, we will be flying in the air. But in an aeroplane, in order to do that, this aeroplane has to move faster in a forward direction, which is done by a thrust force. Okay, and when anything is actually trying to move forward at very high speed in the air, always the air will produce a resistance. It will try to stop the object from moving against the direction of air. This is how the natural tendency is. So two important forces when we when we talk about aeroplane or when we talk about flying objects, there are two most important things that we need to consider. The first one is we have to take care of the drag. Somehow we have to generate a force which is more than larger in quantity compared to this drag force. So if we are able to overcome, if we are producing more force than this drag force, then only we will be able to move in the forward direction. And if we are able to move in forward direction, let's say at high speed flow, let's say Mach number, we will keep it as 2. In previous classes we have seen that Mach number has to deal with flight speed. Okay, higher the Mach number, faster is the speed of the vehicle. So first we have to overcome this drag force. Okay, so let's say if you have 30 Newton of a force, 10 Newton we are losing it in order to overcome this or to resist this drag force. The remaining 20 Newton of a force or kilonewton of force we are applying on this aeroplane. So larger force we apply on this aeroplane, faster this aeroplane is going to move, and the air will move faster over these wings, generating lift. Okay, so this is the whole concept. The idea of gas turbine engine or propulsive unit, here you can see an engine is to push the aeroplane in the forward direction. Okay, in our basically in our car or bike engines we use different kind of mechanism here. So here I have actually compared, we will compare here two types of engine. Here the first one, as you can see, is a gas turbine engine. Here you can see engine is basically a machine which converts this is very wrong, it converts heat energy into mechanical energy. So here we should have heat energy, which is very bad. So here heat energy we are actually converting into mechanical energy. Okay, so the engine has to produce some useful mechanical energy that will be used in moving or maybe upward or propelling something or pushing something. Okay, so here what is the difference between engines that we use in our scooter, in our bikes, and the engines that we are using in an aeroplane? So here two different things you can notice. Basically, a engine, this is a piston engine, this is called a reciprocating engine, or we'll call it as a piston engine because it has a piston. This part is known as a piston. The piston keeps moving up and forth, and then that produces energy. So here there are total 4 cycles which we observe. 4 cycles which this 4 sections which this engine, the piston engine, observes is intake. It will take the air inside and then it will generate us, it will put a fuel in it, or sometimes we have already mixed fuel and air. The only thing we have to do is we have to burn this fuel so that it produces large amount of energy. And this amount of energy is again because of the inertia or motion of the piston. It is pushed, this piston will move upward, and the job of this energy is to push it down. And because of this up and down motion, which is also known as stroke, in piston engine we call this as a stroke. So this is basically 4-stroke engine. The piston is moving 4 times up and down. So this 4-stroke engine will generate energy with the help of a crankshaft, which will be connected to this, which will be rotating our wheels of our car or wheel of our bikes, that it will be rotating. So this engine actually we use when we are talking about a ground-based movement or ground-based motion. But when we are flying in air, it becomes very difficult to use these kind of object. There are many reasons for that. Most important thing is we need to have large amount of air, and we have to do the combustion at a very speed pace. So instead of using these 4 strokes or 4 simple different cycles, we try to combine everything together along a single line. So this is a single line engine, which is we call as a gas turbine engine. Here the 4 basic components of a gas turbine engine you can see here. First there will be, this is an intake. So when an aeroplane is moving in left side direction, the role of this intake or a gas turbine engine, it is to allow as much air as possible, maximum amount of air through this much section, so small area. And because you are moving a very high speed, large amount of mass is going to enter into this intake. And the other sections are, this will be discussing it. It will be a compressor. Job of a compressor is to compress the air, okay, to compress the volume so that it will produce large amount of a pressure. And this high pressure air has to be passed into the combustion chamber, and in the combustion chamber we also pass of a fuel, like we have done burning of a fuel here. This is the combustion section or combustion chamber. Same kind of a burning of a fuel it is done in this particular combustion chamber, and in order to produce even higher pressure, higher temperature. So a high pressure gas is actually burnt to produce high temperature. Okay, so we have here in the combustion chamber we have high pressure and high temperature gas. This high pressure and high temperature gas, then it is bombarded or it strikes the turbine blades. Okay, so these turbine blades, when these high pressure high temperature gases strike the surface of a turbine blade, they starts rotating. Okay, and after this rotation of this turbine will keep the compressor also rotating. Okay, first and most important thing, the compressor and the turbine are rotated here. They are connected here. So the turbine starts rotating. When the turbine starts rotating, the high temperature gas actually, so here the rotation of a turbine produces energy sufficient enough to rotate this compressor, because it has to produce very high pressure. When we start compressing air, the air will start producing resistance. So you need to have more and more power. So this turbine has to provide that much sufficient power or rotation speed so that we will be able to reach certain designed pressure ratio. And the high temperature gas is then exhausted. Here we cannot see the exit. We will see in the jet engines, coming jet engines. So here there will be an exhaust. The high temperature gases, they are exhausted in order to produce a jet, so that we can take use of Newton's third principle. With high speed, if we allow these high temperature high pressure gases to exit, the faster we are able to move through the air. So this is the basic difference between the reciprocating engine that we use in car, we use in trucks, motorbikes, scooters. This is what we use. And then compared to a gas turbine engine or a flying vehicle, everything has to be done in a single flow. Okay, the air comes and then quickly it has to get burnt. And let's say if the airplane is this engine is moving very fast in air, okay, at a speed of Mach number, let's say speed of 300 meter per second, imagine the air will be entering into this chamber at 300 meter per second. Okay, so at such a fast pace, everything has to be done quickly. Everything has to be done very fast, within a second, within a fraction of second. The air has to be compressed, combusted, and then it has to be exhausted. Okay, so this is the major difference between the reciprocating engine, which is used for motion on ground based system, and this is gas turbine engines, which are used for air based